Okay, last topic, right? This is, I think, the last section, 8.5 roughly. And the topic is the binomial theorem. And in fact, I'm not even going to state the theorem in its summation form. I don't think we really need to talk about that here. So here's the idea of it, right? Here's what we want to do, right? So just a couple examples. Suppose we want to expand a plus b squared. Okay, so by now you know that this is not a squared plus b squared. Please, please don't make that mistake again. Right? We've all done this. I know I've made that mistake many times. No, you can't do that, right? Because what does this mean? What is a plus b squared? Well, it means you're going to multiply a plus b times itself. A plus b times a plus b. And that should remind you of FOIL, right? So a times a is a squared plus a times b is the outside. And then b times a, well, b times a is also a times b. And then b times b is b squared. Right? So you have 1ab plus 1ab, that's 2ab. Right? So you can see what happened. That's why this is not a squared plus b squared, because you're missing the middle term, the 2ab. Okay? B squared. Right? So, yeah. So that's that. Well, what if you want to do a plus b to the power 3? Again, by now you know this is not a cubed plus b cubed. Right? Can't be. Because instead, we are going to multiply a plus b times a plus b times a plus b. Yeah, a bit of a nuisance, but we can do it. And in fact, we already did part of it already. I'm going to do the second two here, the product of these. We did that, a plus b times a plus b. Right, so I'll leave this one alone. This is just going to be what we got earlier, a squared plus 2ab plus b squared, right? So we already multiplied this out up here. Okay? Now, the problem is we have to do it again, and we can't even use FOIL this time. The way I think of this is I'm going to multiply the a here times the entire second factor, a squared plus 2ab plus b squared, right? And then do the same thing with the b. That's supposed to be a plus. So plus b times a squared plus 2ab plus b squared. Okay. So now just distribute the a. You get a times a squared is a cubed, right? And then a times 2ab is 2a squared b. And then a b squared, yep, ab squared. Plus, and then b times a squared is a squared times b, plus 2ab times b is 2ab squared, and then b times b squared is b cubed. Yeah, so you get kind of a mess here, but you also get some like terms, right? So we have 2a squared b plus 1a squared b, and that's going to be 3a squared b, right? So this is a cubed plus 3a squared times b. And then we have, again, 1ab squared plus 2ab squared is 3ab squared. Right? And then plus b cubed. So there you go. Right? So this is a plus b cubed. Right? Just expand it out. Well, what if you want to do a plus b to the 4th power? You see where this is going, right? So this is going to be kind of tedious because it's a plus b times a plus b times a plus b times a plus b. Now luckily, we already did most of this already. We did all of this. All of this stuff is all of this here. Right? So all we really need to do now is multiply by another a plus b. and just write all this down here. 3ab squared plus b cubed. Yep. So now, well, we're going to get a times all of this plus b times, again, the same thing. It's an a. So yeah, you can see how tedious this is going to get. That's a 3, right? Yep, so you're going to get a to the 4th, right? A times a cubed is a to the 4th, plus 3a cubed times b, plus 3 times a squared times b squared, plus a times b cubed. It's an a, right? And then for the second 4 terms here, you're going to get b times a cubed, plus 3a squared b squared, plus 3ab cubed, and then b times b cubed is b to the 4th. Wow, right? So yeah, big mess here, but we do get a lot of like terms. 3a cubed b plus 1a cubed b. So that's going to be, start out with the a to the 4th, right? Leave that. And then plus 4a cubed b. Okay, these are all pluses, right? And then we have here, we have 3a squared b squared plus another 3a squared b squared. So that's 6a squared b squared. Yep, 3 plus 3 is 6, so 6a squared b squared. And then finally, we have ab cubed plus 3ab cubed is 4ab cubed. And then finally, the b to the 4th at the end here, right? So there you go. And now, of course, you might want to do a plus b to the 5th. And by now, you're probably getting a headache over this, so I think we'll leave it at that. However, suppose instead of a plus b to the 5th, again, you'd have to do this one more time. But what if you want to do a plus b to the 12th? Now I'm getting a headache just thinking about it, right? Because you're going to have to do a plus b times a plus b times a plus b times a plus b, right? And so on, 12 times. So this was bad enough doing this, 3 times. Now we got to do it, I guess, 8 more times, right? To get to 12. No thank you, right? No thank you. Luckily, we don't have to do this, right? I would never make you do that step by step like that, right? Instead, we're going to use a neat little device called Pascal's triangle. So Blaise Pascal did a lot of work with probability, maybe a little bit of calculus too, but this is Pascal's triangle. So once you know Pascal's triangle, then you'll be able to get this so much faster than the way we've been doing it. Okay, so what's Pascal's triangle? Well, it's a triangle, right? But it's a triangle of numbers. It's a triangle with just numbers in them, right? So I'm going to start at the top with just a 1. And then the next row will have a 1 and then a 1. The next row will have a 1. And then in the middle here will be a 2. And then finally another 1. So you always start with a 1 and you end with a 1. What goes in the middle though? So 1, 3, 3, 1. You see how I got this 3 here? I just added 1 plus 2 to get 3. See that? How did I get this 3? Same thing. This is 2 plus 1. And you get 3. Right? If you like, you can think of this as a 0 here. How did I get this 1? 1 plus 0 is 1. Right? So again, I prefer to think just starting with 1 and ending with 1. Right. So what's the next row? You still start with a 1. 1 plus 3 is now 4. 3 plus 3 is now 6. And 3 plus 1 is again 4. And then finally we end with a 1. So now you can see the triangle forming here, right? Yep. Okay, so let's go on to the next row. This is not hard. Start with the 1, then you add these two numbers above it, right? 1 plus 4 is going to give you 5. 4 plus 6, that gives you 10. 6 plus 4, that's also 10. 4 plus 1 is again 5, and then we end with the 1. So you can see the numbers kind of repeat here, right? They're just reflected in the middle. It's almost like a mirror in the middle here, right? Let's do another row. 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15 again. And 5 plus 1 is 6. And 1 plus 0 is 1. Oops, that's a little too high here. 1. So I think you get the idea, right? You can always get the next row just by adding the numbers above it. 1 plus 6 is 7. 6 plus 15 is 21. 15 plus 20 is 35. 20 plus 15 is also 35. 15 plus 6, 6, we're back to 21 again. 6 plus 1 is 7, and then we end with a 1. So there's the triangle, right? All right, so what does this have to do with what we just did here, right? Remember, our goal was to get a plus b to the 5th power, right? Because that's where we ended. We ended with a plus b to the 4th power, right? And then we were going to go to 12, but I think we skipped the 5, right? We skipped the 5. So yeah, what does this have to do with this problem up here? So yeah, good question. So I'll try to point this out. I think I can do this here. So look at the result here for a plus b to the power 4. Okay. Look at the coefficients. We have a 1, a 4, a 6, 4, and then a 1. Now, where have we seen these numbers before? Look at this row right here. Right? We have a 1, a 4, 6, 4, 1. 1, 4, 6, 4, 1. So you can see that the coefficients here are just the numbers in each row of Pascal's triangle. Okay? So that's how to get the coefficients. What about the exponents? So look at the pattern here. Let's start with the a's. For the a, we start with the biggest power, the 4. Again, the 4 just comes from a plus b to the 4th, right? So what's the next exponent? It's a 3. Okay, well, that's 4 minus 1 is 3, right? What's the next exponent? It's a 2. 3 minus 1 is 2. What's the next exponent? It's not a 0, right? It's a 1. It's just invisible, but it's a 1. 2 minus 1 is 1. And then what's the next exponent? Okay, that's going to be a to the 0. Right? So 4, 3, 2, 1, 0. Right? So the exponent of a just decreases every time. And it's the reverse for the exponent of b. We start with, I got to squeeze this in here, b to the 0, then b to the 1, and b to the 2, b to the 3, b to the 4. So 0, 1, 2, 3, and 4. Okay. So with that in mind, I think we can probably figure out now a plus b to the 5th without having to multiply all this out again, right? Remember what a nuisance that was. Now we should be able to get it pretty quickly here. So a plus b to the 5, you can see that's the 5th row of Pascal's triangle. These numbers here. So we have a 1, a 5, a 10, a 10, 5, and then a 1. And these are all pluses. I'll show you what happens when, say, you have a minus b. Then the signs just alternate. But these are all going to be pluses here, right? Okay, remember for a, we start with the biggest exponent, that's the 5, a to the 5th, right? And then we get a to the 4th, a to the 3rd, a to the 2, a to the 1, and then a to the 0, although we don't have to write a to the 0 because I hope you remember that a to the 0 is just 1. So 1 times a to the 0 is 1 times 1, which is still 1. Okay. What about the b's? So the b's start at the bottom. They start at not 1, but b to the 0, right? Though if I'm going to do that, I'll put a to the 0 here as well, right? So what comes after 0? 1. What comes after 1? 2. Then 3. Then 4. And then 5. Okay? So there you go. Let's not write the b to the 0, and we don't need to write the 1 in front either. So this is just a to the 5 plus 5 a to the 4th times b plus 10 a to the 3 times b to the 2 plus 10 times a to the 2, now b to the 3, plus 5 times ab to the 4, and then plus 1 times b to the 5. So just b to the 5. And that's it, right? That's a plus b to the power 5. Now, you might be thinking, well, if we did it this way, would it really have been that much longer? Maybe not. Maybe not. However, if you are going to do a plus b to the 12, it's probably easier to get Pascal's triangle rather than multiplying this out, 12 times here, right? Yeah, that would take a few hours, and we don't have a few hours, right? So no. So we're not going to actually do a plus b to the 12th. Even just writing it down is going to take a while, right? Think of how many terms there are going to be, right? There are going to be 13 terms here, right? Why not 12? Well, look, this was a plus b to the 5. There's 1, 2, 3, 4, 5, 6 terms. So there's one more than the exponents. Make sense? So yeah, we're not going to write out all 13 terms here, right? Because first of all, that would also mean we need another 5 rows of Pascal's triangle, and that would take a while as well. So I think I'm going to leave it at that for Pascal's triangle, but we'll do another example of using Pascal's triangle to expand, say a binomial to some power. So let's expand. How about 2x minus 3y to the power 4? Okay. Well, now you have two ways of doing this, right? One way, of course, is just to multiply 2x minus 3y, 2x minus 3y, 2x minus 3y times 2x minus 3y. Not fun, not pleasant, right? It'll take a while, but look, we did it already, right? We did it for a plus b to the 4th, right? So it's on the one hand, you can just replace a with, I think it was 2x, and then b with negative 3y. So we could do that here if you want. Right, you can think of that as a formula here. Instead, let's use Pascal's triangle. And in fact, this is to the 4th power, so we're going to use the 4th row. So let me remind you, that's just 1, 4, 6, 4, 1. So when we write this out, we're going to get 1, 4, 6, 4, and 1. And for now, they're all going to be pluses. They're all going to be pluses, right? So my a here is 2x, and my b is negative 3y. So let's write that down. A is 2x, b is negative 3y, right? So for the first term, you're going to get a to the biggest power. That's going to be the 4 here. I don't need to do that. So this is going to be, instead of a, it's going to be 2x to the power 4, right? And then for the next term, we get the same 2x, but now to the power 3. And then the 2x to the power 2. And then 2x to the 1. And then 2x to the 0, although that's just 1. And now let's look at the b. The b terms, or the b factors rather. We have negative 3y. Right? But remember, this has to start at 0. Right? Then we have negative 3y to the 1. negative 3y to the 2, negative 3y to the 3, and negative 3y to the 4. And so, yep, we end up at 4. So what would happen if we started at 1 here? Then we would have an exponent of 5, but we're only going up to 4, so there's no way we're going to get x to the 5th, or y to the 5th, right? All right. Now, we still have to expand all this out, but that might not be that hard. It's, I mean, you might want to get out your calculator here. 2 to the 4th is 16, so this is just 16x to the 4th. All right, now what do we have? Now we have 4 times 2 cubed, so that's 4 times 8 is 32, and then times negative 3 is going to be negative 96. Oops. 96. And then we have x to the power 3, and then y to the power 1, so just y. And then for the next term, we have 6 times 2 squared times negative 3 squared. Okay, so 6 times 4 is 24. And then times 9 is going to be 216. So this is going to be plus 216 x squared, y squared. Why is it plus? Because it's a negative times a negative, right? It's a negative squared. There we go. Okay, and then the next term we're going to get, we're going to get negative 27 times 2 times 4. So negative 27 times 8 is, 216 again, but it's now negative 216 times x times y cubed. And then plus, so remember, anything to the 0 is 1, so this is just negative 3 to the 4th, which is positive 81 times y to the 4th. And that's it. We're done. I dare say that if you were doing it this way, you're probably still halfway done, right? I think this probably was a little bit faster than multiplying it out 1 by 1 by 1 here, right? Anyways, maybe not. Maybe it's about the same. Maybe you're almost done. But using Pascal's triangle, that makes this, multiplying this out, usually a little bit easier. Okay? So I'm not going to get into the combinatorial stuff. See, these coefficients here in Pascal's triangle have to do with combinations. So, for example, this number here, so this is the 0th row for Pascal's triangle, the first row, second row, third row, fourth row, fifth row, sixth row. So this is going to be what's called 6 choose 3. So if I put, let's say I have a hat and I put 6 names in it, and I want to take out 3 of the names. So how many different ways can I choose 3 names out of the 6? It turns out there's going to be 15. Same as this number here. Wait, 1, 0, 1, 2. Oh, I'm sorry. This is 6 choose 2, not 6 choose 3. Oops. So I want to pull out 2 names out of the hat, not 3 names. There we go. You have 6 names in a hat, pull out 2 of them at random, then you have 15 ways of doing it. Okay? Yeah. If you pull out 3 names, there's 20 ways of doing that, and that's the 20 here, right? How many ways are there to pull out 0 names? Well, there's only one way to do it. Just leave the hat as it is. Don't take anything out. So that's one way. So that's this one over here. You get the idea, right? So this has to do with combinatorics and probability, but I think I'll just leave it at that. So by doing that, you can write a plus b to the n in combinations. So this is the what's usually stated as the binomial theorem. And since that's the title of the section, I guess we should show you what it is. So it's going to be the sum of, let's say, k going from 0 to n of n choose k times a to the n minus k times b to the k. So that is the binomial theorem. And using this, we could have written this out in much the same way. So if you don't know what this symbol is here, again, that's a probability question or a summation question. This just means sum. So I'm adding up all these terms, right? Because that's what you're doing. You're just adding or subtracting. Oh, why is it adding and not subtracting? How do I get the minus sign? Because you're subtracting here, right? The 2x minus the 3y. And you can see that whenever you have an odd exponent, you leave it as negative. So for the 1 and the 3 here, you have these negative signs instead of positive. When you have a negative, to a power 2, right, to an even exponent, then you get a positive. Right? So, yeah. Okay, so I really should leave it at that. I think this is a good enough example. If you want another one, and I'll let you do this for homework, suppose you just want to do x plus 5. No, let's just do x plus 5. X plus 5 to the power 3. Expanding using the binomial theorem, right? In other words, use Pascal's triangle here. Right. Obviously, you can also just multiply x plus 5 times x plus 5 times x plus 5, and that won't take you too long, but I still maintain that this is going to be quicker. In fact, let's do it. So this is going to be 1, 3, 3, 1, plus, plus, plus. Right? So this is just going to be x to the 3, x to the 2, x to the 1, x to the 0. But then the b term here is 5. So you're going to get 5 to the 0, 5 to the 1, 5 to the 2, and 5 to the 3. So you just get x cubed plus 5 times 3 is 15x squared, plus 25 times 3 is 75 times x. And then 5 to the, that's a 5, sorry, not a 3. 5 to the 3 is 125. So how are you doing this way, right? Yeah, it's like I say, it wouldn't take you that much longer, if at all. But using Pascal's triangle usually saves you a little bit of time. So that's Pascal's triangle. Again, make sure you know how to get each subsequent row after it. And then by using that, you can get, a plus b squared, a plus b cubed, a plus b to the 4th, without having to go through all this horrible algebra up here, right? Which, it's not terrible, but it's tedious, and it's long, and it's confusing, and if you're not careful, you can mess up here, right? So, okay, so that's it. That's the course. We're done. Binomial theorem is kind of a weird topic to end on, but it's going to become relevant, if you take pre-calculus or calculus, or even a course like probability or statistics. It might come up. I'm not sure. Probably not in your statistics course, but it could come up in other contexts. So so good to know. Not a big part of the course, but it's our final topic, and so I hope. I hope you enjoyed this as much as I did. I mean, for some of you maybe, but for a lot of you I kind of doubt it. And I'm sorry about that. I didn't, I don't mean to bore you to death here. But this is it. And especially under all these really trying circumstances, I know this is not ideal because I know you're not, I can't answer your questions in real time. I can answer your questions on email, and some of you have sent me emails, and I responded in pretty good time, usually by the next day. And I'm sorry to make you dizzy by this, but I'll leave it here. So I just want to thank you for sticking it out. And I have the utmost respect for all of you that are gonna, that are gonna finish, that are gonna do this till the end. This is not easy to learn on your own. And I know that most of you really felt like, you're doing this on your own. And I feel terrible about that. I really, really miss teaching. I miss being in front of class. I miss taking your questions. And whenever I make a mistake, there's always someone in class that'll probably point it out. Instead, I had to find my own mistakes, and I just hope that I did. In most cases, I do, but you never know. If you see me doing anything wrong, please send me an email, and I will correct it, or I'll correct it in the description maybe. If it's a really egregious mistake, I will just do it all over again. But so that's it. I will try to make a review video for test 4 and then the final as well. So the final is coming up soon. Obviously test 4 is just next week. So this should be enough. So maybe I should just recap what's going to be on test 4, even though I'm going to do that in the review video too, I guess. All right, so test 4, of course, is everything from chapter 4, starting with logarithms. So 4.3, 4.4 is properties of logarithms. 4.5, you're solving equations with logarithms. And 4.6 was that, those applications, carbon dating or populations or radioactive decay, those kind of things. And then 5.2 was the solving equations, systems of equations, right? So 3 equations and 3 variables, that kind of thing, right? And then 1.7, we jumped all the way back to 1.7, and that's going to cover the inequalities and it's going to cover absolute value, right? Absolute value, equations, and inequalities, which we just did. And then finally, I think this is 8.5, right? Yep. 8.5 is the binomial theorem. 8.5. So that's binomial theorem. And actually, it's really just Pascal's triangle and then expanding binomials to the nth power. Right? So can you calculate a plus b to the 5th power if you had to? So I hope that helps. And again, please ask questions. If you have any questions on any of these topics here, or in fact anything, even for the final, please just send me an email, and I will do my best to answer. So, this was a really great course. Again, maybe not ideal when halfway we had to do it this way, but I hope these videos help. Again, if they don't, you can look at other videos, right? You can go back to Khan Academy and look at some of those videos. They may be more helpful. Some of you find them more helpful. Some find less helpful. It's an individual thing. So it just depends on your personal preference. All right. Well, that's college algebra. So thank you for sticking it out. And some of you I might see in pre-calculus. Actually, I take that back. I'm not doing pre-calculus this summer, and I'm not doing it for a while. So unless you're going on to calculus, enjoy whatever math courses you're taking next. And have a great summer.